everyone, welcome to my YouTube channel. This is Mommy J, and if this is your first time here, please do subscribe and turn on notifications for updates. Okay, so on these slides, we will be solving quadratic equations using the quadratic formula. Okay, so with the quadratic equation ax squared plus bx plus c equals 0, we are going to get those coefficients a, b, and c and substitute it to the quadratic formula. So as you can see, a is the coefficient of x squared. We will substitute it there and here. B is the coefficient of x, or the middle term, this one. And c is the constant. Remember that the quadratic equation should be in standard form. Ax squared plus bx plus c equals 0, or everything or every term is on one side of the equation and then equal to 0. Okay, so let us try this one. 2x squared plus 13x plus 15 equals 0. So we have here a equals 2, b equals 13, and c equals 15. Now, assuming that we already have memorized the quadratic formula, so that will be x equals negative 13 plus minus the square root of b squared, 13 squared minus 4ac. So that's 4 times 2 times 15 all over 2a, which is 2 times 2. So negative 13 plus minus the square root of 13 squared is 169. Now 4 times 2 times 15 is 120. All over 2 times 2, which is 4. Okay, next, simplifying everything, we have x equals negative 13 plus minus the square root of 169 minus 120 is 49 over 4. So negative 13 plus minus square root of 49 is 7 over 4. So we will be having two values of x here. The first one is negative 13 plus 7. So that is negative 6 over 4, which is equivalent to negative 3 over 2. The second value of x is negative 13 minus 7, which is negative 20. And then over 4, that is negative 5. We can write our final answers in this form. The values of x are negative 3 over 2 and negative 5. So there you go. These are the values of x that will satisfy the quadratic equation. Okay, let's try another one. So first, again, we have to identify the values of a, b, and c. A equals 2, b equals 7, and c is equal to negative 15. So don't forget to include the signs whenever there is a negative sign in the coefficients. So x is equal to negative 7 plus minus the square root of 7 squared minus 4 times 2 times negative 15. All over 2a, so that would be 2 times 2. Negative 7 plus minus the square root of 49 minus, oh, there are two negative signs here. So when you multiply this negative 4 and negative 4, and that negative there, negative 15, that will become positive. So that will be 4 times 2 times 15, which is 120 over 4. So negative 7 plus minus 49 plus 120 is 169 over 4. Again, simplifying everything, negative 7 plus minus the square root of 169 is 13 over 4. So the first value of x is negative 7 plus 13. So that's positive 6 over 4, which is 3 over 2. The second value of x is negative 7 minus 13, which is negative 20 over 4, which is equivalent to negative 5. So we can write the values again of x in this set form. 3 over 2 and negative 5. Okay. Next, let's try this one. So what's the value of a here? So this is a common mistake of students. X squared. They write a equal to 0. That's wrong. So a here is equal to 1. So whenever you don't see any coefficient on x squared or x, that is equal to 1. Now b is equal to negative 9 here. Don't forget the negative sign. C equals 18. So substituting to the quadratic formula, x is equal to negative b. So that would be negative of negative 9 plus minus the square root of b squared. So negative 9, square mo yun, minus 4ac all over 2 times 1. Okay? So negative of negative 9 is positive 9 plus minus. When you square a negative number, negative 9 squared, that's positive 81. And then 4 times 1 times 18, that is 72. Over 2 times 1, which is 2. Then simplifying, 9 plus minus the square root of 81 minus 72 is 9 over 2. And then we have x equals 9 plus minus the square root of 9 is 3 over 2. So we have here values of x, 9 plus 3, which is 12 over 2, 6. And the second value of x is 9 minus 3, that is 6. And then over 2, 6 over 2 is 3. So our solution set for this quadratic equation is 6 and 3. Now it doesn't matter what you put first. You can write 3, 6. It's okay. Okay. Now, in this example, we can see here that the quadratic equation is not in standard form. So, first thing you need to do is to transpose everything on one side of the equation. So, that will be 3x squared. 11x to the left side, that will become negative 11x. And then 4 will become negative 4 equal to 0. Okay? So don't forget that. The quadratic equation first should be in standard form. And then after which, we can now identify the values of A, B, and C. So A here is equal to 3, B equals negative 11, and C equals negative 4. Okay? So X is equal to negative of negative 11 plus minus the square root of b squared minus 4ac, 4 times 3 times negative 4, all over 2 times 3. Okay? So we have positive 11 now. 11 plus minus the square root of negative 11 squared is positive 121. Now we have two negative signs here, negative 4 and another negative 4. When you multiply it, that will become positive. Now 4 times 3 times 4, that's 48. Okay? All over 6. 2 times 3 is 6. And then again, simplifying everything, we will have 11 plus minus the square root of 169 all over 6. So 11 plus minus, again, the square root of 169 is 13 over 6. So the first value of x is 11 plus 13, which is 24 over 6. That's 4. And the second value of x is 11 minus 13, negative 2 over 6, which is negative 1/3. Okay, so we can write our final answers like this. So the values of x, or the solution set for this quadratic equation, is 4 and negative 1/3. Okay. Okay, next, let us try this one. Now, as we can see here, the right side is already equal to 0, but it's not a trinomial, but still this is a quadratic equation. Now, let us identify what are the values of a, b, and c. A equals to the coefficient of x squared. So we cannot see here a middle term, which is x. Therefore, b is equal to 0 and c is equal to negative 18. Okay, so substituting this a, b, and c in the quadratic formula, so we have negative 0, or 0 plus minus the square root of b squared, so 0 squared minus 4ac all over 2a. So that will be 0 plus minus the square root of, so inside the radical sign we have 0, negative, negative, so that will become positive. 4 times 2 times 18. So what is that? 144. 2 times 2 is 4. So that will be 0 plus minus. We can just write plus minus. Then square root of 144 all over 4. And then the square root of 144 is what? 12 over 4. So the values of x here are positive 12 over 4, so that's 3, and negative 12 over 4, which is negative 3. So the solution set for this quadratic equation is negative 3 and positive 3. Okay. Okay, another example. So again, we should write first in standard form this quadratic equation, x squared minus 11x. So you're gonna transpose 11x on the left side so that the right side will be equal to 0. And then identify the values of a, b, and c. A is equal to 1, b equals negative 11, and c equals 0. Okay? So again, x equals negative of negative 11 plus minus the square root of negative 11 squared minus 4ac. So all over 2 times 1. So that will be positive 11 plus minus the square root of 121. Now this is 4 times 1 times 0. So that will give us 0 here over 2. Okay? So 11 plus minus the square root of 121 over 2. And then we will have 11 plus minus, now the square root of 121 is 11, and then all over 2. Again, we have two values of x here. 11 plus 11, that's 22, all over 2, which is equal to 11. And the second value of x is 11 minus 11, which is 0 over 2. And 0 over 2 is 0. Okay, so the values of x or the solution set for this quadratic equation is 11, 0. Okay, how about this one? Again, always remember that the quadratic equation before using the quadratic formula should be in standard form. So everything, let's try to put everything on the left side, combining like terms. So with 5x squared and x squared from the right side, transposing x squared on the left side, we will have 4x squared. 4x squared. Then negative 7x plus 2x is negative 5x. Negative 1, the constant would also be transposed on the left side. We will have here positive 1. And the right side will be equal to, of course, 0. Okay? So with this standard form, we can now identify A, which is 4, B, which is negative 5, C equals 1. So substituting to the quadratic formula, negative B, so negative of negative 5, plus minus the square root of B squared minus 4AC all over 2 times 4. So that will be 5, positive 5, plus minus, now negative 5 squared is 25, 4 times 1, so that is 16, all over 8. So simplifying again, we have 5 plus minus 25 minus 16 is 9 over 8. 5 plus minus the square root of 9 is 3. And then over 8, we have two values of x. 5 plus 3 is 8. And then over 8, which is 1. Second value of x is 5 minus 3, which is 2 over 8, 1/4. So the solution set for this quadratic equation is 1 and 1/4. Okay, I think this is the last example for this. It's already in the standard form. We have A equals 1, B equals 1 also, and C is equal to negative 5. So substituting to the quadratic formula, x equals negative 1 plus minus the square root of 1 squared minus 4ac all over 2a. Negative 1 plus minus the square root of 1, so that would be negative times another negative, that will become positive. 4 times 1 times 5, so that is 20. All over 2. Okay? So simplifying this expression, we have negative 1 plus minus the square root of 21 all over 2. Now we cannot anymore take the square root of 21 as a whole number. That's it. So the solution set for this quadratic equation is negative 1 plus the square root of 21 over 2 and negative 1 minus the square root of 21 over 2. Okay, sometimes your teacher can accept this as final answer, negative 1 plus minus the square root of 21 all over 2. Actually, that's really acceptable. Okay, now you can actually use quadratic formula to any kind of quadratic equation as long as you have transformed it into standard form. Again, everything, you can write everything on the left side and then equal to 0. Okay, so that's it for today or for these slides. Don't forget to subscribe and turn on notifications for more updates. Thank you.